Hello again, grade 8s. In today's lesson, we're going to begin the lectures for the final unit of study in grade 8 science on fresh and saltwater systems. And we're going to do so by looking at the water distribution on the Earth. And what I mean by that is looking at like what percentage of the water on the Earth is salt water, which percentage is fresh water, and then taking fresh water and identifying what are all the different categories of fresh water and where can we find it. At the end of the lesson, we're going to tie that into a bit of a math application where we're going to construct a circle graph to show the percentage of different types of fresh water on the Earth. Let's start off with salt water. So salt water makes up nearly all of the percentage of water that you find on Earth, somewhere around 97.2%. Salt water is found in the oceans and seas. So you have a picture here, we can see like all the different, a few of the different oceans: Pacific Ocean, Arctic Ocean, Atlantic Ocean, etc. And salt water, and specifically the oceans, can have a major influence on climate. So the example I want to use here is if you're to take like this area in Europe, so it's kind of like in the Great Britain type area. And if you're to compare it to like a similar area in North America, like if you went all the way across, okay, it would kind of like line up with like where Hudson's Bay is. Now, it turns out that the climate in Europe in this area is actually a lot milder. It's a lot warmer in comparison to a similar location in North America. The reason being is because there is some ocean water that starts I think it starts somewhere off like the east coast of North America. And basically this warm water makes its way all over to that west side of Europe. And this warm water that makes its side over to the west side of Europe has a significant influence on the climate. So it actually makes the climate a bit warmer in this area, even though at a similar spot on North America, it would be much cooler. Saltwater is home to more species than any other place on Earth. I show this video typically to my grade 7 students, but there's a DVD series, or just maybe not even a DVD series, but there's I want to say it's from like BBC called the Planet Earth series. And they actually have an episode that focuses on the deep ocean. And it's a really interesting episode because they go quite a bit below the surface of the ocean, and like way beneath the surface of the ocean, there's some like really weird and strange looking species down there. I mean, you can see an example of that on the right side picture here. This like, I don't know what that thing is, aside from the fact that it looks like it has a bunch of like jagged teeth that I would want to have nothing to do with. But anyways, I highly recommend you watch that episode if you've not seen it before. And obviously, and the unfortunate thing is, despite the fact that most of the water is salt water, 97%, we can't drink any of it, nor can any other land organism. So much water, but we can't drink it. Second category, we have fresh water. So fresh water makes up about 2.8% of the water found on the Earth. So it's close to that remaining 3%. And this is needed by humans and other land organisms to survive. So again, the salt water is not sufficient for us to survive. The salt is a major problem. And we can take fresh water and we can break it up into 3 distinct categories. The first category of fresh water are glaciers and polar ice caps. And the example I've shown here is the Elephant Foot Glacier in Greenland, which is humongous. This is fresh water, except it's frozen. So once again, I shouldn't say once again, but this is not really accessible to us to drink. And of that fresh water amount, it actually makes up like a good chunk of like the total amount of water on Earth. So about 97% of all water on Earth is salt water. We can't drink it. And then another 2.15% of that is frozen water, which again, we can't drink because it's not really accessible to us. We also have groundwater. Groundwater is fresh water that's found beneath the Earth's surface. Now, this water can be accessible. I mean, you might have like a well or some kind of pump that can pump that water up. But for the most part, it's still not great in terms of accessibility. But nonetheless, it's at least more accessible than the glaciers. And of the all the water on the Earth, it makes up about 0.63% of that water. So not a whole lot, less than 1%. Surface water, that's the kind of water that we can drink. So surface water would be lake water that you find in lakes. Again, on the image on the left-hand side, we have an image of the Great Lakes. On the right-hand side, we have a picture of Calgary, where you have the Bow River that's flowing through it, and the Bow River being like a major source of water for us in Calgary. Surface water is fresh water that's found above the Earth's surface, on the Earth's surface. It only makes up a really, really, really small percent of all the water that's found on the Earth. So of 100% of all water found on the Earth, only 0.02% of that is surface water, the kind of water that's accessible. Here's a little illustration just to drive this point home to show how little water is actually accessible for us. So this illustration shows a bunch of water droplets, and there's actually like there's 100 of them if you count them out. It's essentially a 10 by 10 grid of these water droplets. Okay, so there's 100 water droplets, which you can think of as representing 100% of the water on the Earth. Of these 100 droplets, there's only this small amount that would fall into the freshwater category. So 97 out of 100 of these droplets would be salt water. We can't drink it. 3% or 3 droplets, we can drink it. But of those 3 droplets, a little bit more than 2 is frozen water, cannot drink it. Of that remaining droplet, a bunch of that is groundwater, which can be accessible, but not easily. And then you have this really small, tiny little bit, like kind of like the tip of the droplet right there, which would actually be the surface water that is available to us. So much water, but so much of it that we cannot actually drink. Now, I want to tie this into a math example where I show you how we can construct a circle graph. This will have a bit of a tie into the last unit of study in math, where we talk about data representation and circles being one type of graph that we'll look at. I have a table that shows the 3 different freshwater sources. So we're not worrying about salt water here, just the freshwater. And what I have is your 3 freshwater sources are glaciers and ice caps, groundwater, and surface water. Of the total percent of fresh water, glacier and ice caps make up 76.8% of that. Groundwater makes up 22.5% of that. And then surface water only makes up 0.7% of this. And I want to construct a circle graph by hand. If you were in the classroom here, I could do this on the whiteboard using a gigantic compass and a gigantic protractor. But obviously, since we're not in the classroom, I'm going to need to find a different way to illustrate this to you. So I'm going to go to a Smart Notebook file to show you how this works. Okay, so let's go over to my notebook file. All right, so here are the different categories of fresh water. Now, the first thing I need to do is draw a circle. You don't need to do this because the circle is already drawn for you. I'm going to use a compass to do this. So the way to draw a circle with a compass is basically you have like a pointy edge of the compass, you have a pencil edge. The pointy edge of the compass represents the center of the circle. And let's just do this over here. So yeah, the pointy edge represents the center of the circle. And then the pencil edge, when I kind of like draw it around, is going to it's going to draw the circumference of the circle. So let's make this a little bit bigger. Let's draw a circle. So let's go ahead and go around in a circle and draw this. Okay, let's get rid of this. I don't need the compass anymore. And I'm going to draw a line from the center of the circle, a horizontal line, which is going to serve as like my reference point. So do a horizontal line, and the center of the circle looks like about, I don't know, right here maybe. And let's go straight across. To draw a circle graph, I need to draw different sectors of the graph. Now, to draw the sectors of the graph, I need to know which angle these sectors sweep through. So what I have to do is I need to take these numbers and I need to convert them into an angle that's swept through in the entire graph. Okay, so here's how we do this. What you know is that there is 360 degrees in a full circle. If you started at this right edge of the circle and you went around the circle one time, that'd be like going through a 360 degree angle, in which case 360 degrees means you're back to where you started. Okay, so I need to calculate the angle that these percentages would correspond to. So here's how I do this. So let's do the first one. So let's do glaciers and ice caps. I'll just abbreviate that as GIC, glaciers and ice caps. So to figure out that angle, I need to know what 76.8% of 360 degrees is. To find a percentage of a number, what you do is you first of all take that percentage, turn it into a decimal, 0.768. We did this in an earlier math unit. When you find a percentage of a number, you're multiplying by it. So you're going to go 0.768 multiplied by 360, and then this would be equal to 0.768 times 360 would be 276.48 degrees. Let's round this down to 276 though. When you round a number, you only round once. So if I'm rounding to the nearest whole degree, then I would just look at the digit that follows. So that 0.4 would cause it not to round. Get groundwater, we'll abbreviate that as GW. And that's going to be 22.5% of 360. So that would be, turn that percentage to a decimal, 0.225, multiplied by 360 degrees. And then that's going to be 0.225 times 360 is going to be 81 degrees. Exactly. Okay, surface water, we'd have SW. So that's 0.7% of 360. And 0.7% to convert it to a decimal, divide by 100. So 0.7 divided by 100 would be 0.007. Multiply by 360 degrees. And this is going to give me 0.007 times 360 would give me 2.52 degrees. But let's round this to the nearest whole degrees. We're going to change that to 3 degrees. Okay, now to draw these sectors of these angles, I now need to use a protractor. So I'm going to go grab a protractor tool. And this protractor is a bit finicky to deal with. I'm going to try to shrink it a little bit. Okay. So what I want to do is I'm going to start off by taking the protractor. I'm going to put it at the center of the circle. And I'm just going to make it expand outward like this right here. Okay, what I want to do is I want to make a mark at 3 degrees. Okay, so I'll do the, actually, you know what? Let's do, let's do the smallest angle first, okay? Because the biggest angle is actually is kind of tough to draw. So let's do the 3 degree angle first. So what I want to do is I want to make a little mark at the edge of the protractor at 3 degrees. So you got to count up here. So it'd be like 0, 1, 2, 3 looks like about right here. Okay, so I made a little point off to the side. Okay, at about 3 degrees. Okay, now I'm going to remove the protractor for a second. So I got my little tiny red dot there. And now I'm going to draw a line from the center of the circle to basically the little marking I made in the protractor. So I'll go grab a line. Let's just do it in, yeah, black's fine. And let's go from the, let's make it thin. And let's go from the center of the circle to roughly about this point. Okay, now I don't want this line to stick off the protractor, so I'm just going to make it so the line just stays the same, points in the same direction, but just kind of comes inward a bit. Okay, so that's my first sector of the circle. And we can go ahead and we can label this actually. So let's label it in, let's do red. Okay, and normally I'd write down the words inside the sector, but it's so small I can't fit it. So I'm just going to draw it off, put a little line off to the side here, and I'm just going to say surface water. And I'm going to identify in brackets which percentage it is, and the surface water is only 0.7% of the total. Okay, the next thing I'm going to do is I'm going to do the next smallest angle. So we're going to do the groundwater angle of 81 degrees. So I'm going to take my protractor again. Let's put it at the center of the circle. And I'm just going to match this to the size of the circle. Now, you're not going to be able to do that. I doubt your protractor will be the exact same size. Now, what I want to do is I need to rotate this thing so the base of the protractor is actually on top of that line that I drew for the surface water sector. So I'm going to rotate this. Okay, so that it's sitting flat on top of this line. Okay. Now, starting from there, I'm then going to count up to 81 degrees. So we have 10, 20, 30, 40, 50, 60, 70, 80. And then I would have 81 is going to be somewhere at the top here. So let's just go ahead and try to label that point. Okay, so 81 is about right here. Okay, a little bit about right there. Okay, so I'm going to remove the protractor now and grab a straight line again, and we'll do black, do line, make it black. Okay, and then I go from the center of the circle now to this spot. And again, I don't want this line to go off the circle graph, so just keep it so it's pointing in the same direction. And roughly about right there. Okay, now I'm going to label this sector. So let's go back to my writing tool. And I was doing this in red pen, so I'll just be consistent with this. So this is going to be, this is the groundwater. So I'll write down groundwater. And groundwater is 22.5%. Okay, so I've labeled that sector. Now, to get the final sector, you actually don't have to do anything, because if you have 3 sectors total and one sector is surface water and one sector is groundwater, then the remaining sector here would actually just be the glaciers and the ice caps. So, I mean, if you want to, you can use the protractor to try to measure it out, although it's a bit tough because you actually have an angle greater than 180. So if you want to measure 276 degrees, what you'd have to do is you would have to, I'll just show this quickly. Okay, so go to the center of the circle, rotate this thing. So you have to start here. Now, what you'd have to do is you'd have to first of all measure a 180-degree angle and mark it kind of at the bottom. And then you'd have to add the remainder of the angle in here. So 276 degrees minus 180 degrees would be, I think, like, what is it? 276 minus 180 would be 96 degrees. So you'd have to like make a mark at 180 and then add the remaining 96 degrees, and you should come back to where you started. But there's really no reason to do that because the sectors must add all up to 100% anyway. So we can just fill that in without measuring it. Okay, so let's go to red, and then we'll do this. We'll write down glaciers and ice caps. And then in brackets, we'll write down the percentage. So the percentage here would be 76.8%. And then the final thing I'll do is I'll write a title above the graph. Okay, so above the graph, maybe I'll write down something like freshwater sources. And underline that title. Okay, that looks like a pretty good circle graph to me, drawn by hand. And let's go back here, look at the last slide. And so that's it for this lecture. And then now you can complete in your fresh and saltwater systems, I think it's topics 1, 2, and 4 work booklet, do the assignment called water distribution. And I'll talk to you in the next lesson.